So curve sketching, there's where we left off. First derivative. We had done increasing, decreasing, everything up to here. So let's do second derivative to get concavity. And yes, I do have to again do power rule. I'm sorry, quotient rule. So there we go. Low minus 2 squared. D high 2x minus 4. Low D high. Minus high x squared minus 4x. D low. I'm going to do a power rule, but a very many chain rule in there. So I'm doing the power rule, bringing the 2 down, keeping the x minus 4, that's the g in the power rule. I'm sorry, g in the chain rule. Subtracting 1 from the exponents is the first power. And then really doing the chain rule times the derivative of the inside, which is x minus 2. That derivative will be 1. All over the low squared, which is x minus 2 down to the 4th. I'm doing quotient rule. Low d high minus high d low over low squared. Yeah. Right. Unless you were studious and decided to do it on your own. Right? Is that right? Right word?
Context clues.
Yeah, exactly. Thank you, Adam, for checking my work on that word. And then I had to do the derivative of the low, I had to do a chain rule. Bring the 2 down, but keep this as the g, subtract 1, derivative of this is the 1. Okay, now I'm going to set it equal to 0, and the denominator is all right, but I need to really simplify the numerator. Now, to help simplifying the numerator, there's one big term here, minus there's one big term here. And each of those terms has an x minus 2 in it. Oh, right. Why did I write x minus 4?
I don't know. They said don't write that down.
Sorry about that. So each of the numerator terms has an x minus 2 in it. The bottom is x minus 2, right to the 4th. I can cancel out an x minus 2 from each of those terms, and 1 from the bottom. I'm going to show you what I'm really doing. It's really a GCF and then cancel. Just to show you my full work here. From this term, I'm factoring out an x minus 2. Now I'm going to write what I'm left with. Well, there's still an x minus 2 here, right? Because it was squared.
Yep.
So there's an x minus 2 left, and then the times 2x minus 4.
So this is second derivative.
Minus, here I factored out that x minus 2, right, so that's gone. So there's a 2 left, 1 times 2, and then there's an x squared minus 4x left. Yes, you could have already simplified that if you wanted.
How do we get rid of 1?
Yeah, and then on the bottom is x minus 2 to the 4th. So, okay, the reason I showed you, sometimes I just cancel that, but I wanted to show you what I'm really doing. Factoring out a numerator GCF x minus 2. Then I'm canceling this with 1 here, and so it makes it cubed. And what it did is it made our work in the numerator a lot easier.
Yep.
Otherwise, I would have had to FOIL, then distribute that. That would have been pretty complicated.
It's already complicated, so
Yeah.
It would have been even more, though.
this would be less complicated. It would just be like, answer is A.
We should go back to stack. What's a GCF?
I'm glad, Bobby. I'm glad you like these.
Basic addition. Exactly. I have no idea.
Oh,
What's
that's
the
great.
inverse of multiplication?
What is
Oh, yeah.
multiplication?
I obeyed what you said. Oh,
Multiplication, I guess.
I love this. Can we do times test, please?
I was typing in, I guess it was or keep on going.
okay. Okay. No, I'm glad you did it. What?
We do times test. There's
Yeah.
basic
Yeah,
multiplication.
and remind
No.
you, please no, me no.
Okay, so I canceled that out. Now I'm going to simplify the numerator. The denominator is good.
Cool.
X minus 2 cubed. But I'm going to FOIL the numerator and distribute the second part. So this is going to cancel. So right here I'm just distributing. X times 2x is 2x squared. X times negative 4 is negative 4x. There's another negative 4x. There's a positive 8. And then over here, it'll be negative 2x squared, and then 8x, just
Does
distributed.
the 4x's cancel out?
No,
No, they don't.
they don't. However, there's a lot that is going to cancel out.
But they don't make a negative. Never mind.
Make it
Yeah,
negative 8.
they'll make it negative.
So here's what cancels out, the 2x squareds.
Okay.
That's negative 8x, and that's 8x. Right, so those all cancel
Oh,
out.
I knew it canceled somewhere.
Yes, yes.
That's why I'm a genius.
So it's 8 over x minus 2 cubed.
Wow, how does it
Right.
Just got
all
so
that work
small.
for that little thing?
I know, isn't it great?
No.
Oh. Alright, so yeah, second derivative, we simplified a lot, got there. That's great. We now need any, not critical points this time, possible points of inflection. That's just where the numerator or denominator is equal to 0. 8 equal to 0. Not true, won't give us any solutions. However, the bottom, when I set it equal to 0, x minus 2 cubed equals 0, I'm going to get 2. Right, if I do a cube root to both sides, it'll be x minus 2 here, and the cube root of 0 is 0, and then add 2. So we can't call it a point of inflection yet. We got to check concavity. And so I'm at the number line for 2. So let's plug in 3 and 0.
Why 0?
It's easier to plug in than 1.
Fine.
But if you want to plug in 1, you can. It's good.
Nope.
I just like, yeah, I like 0. If I can do 0, that's the first one I go for.
You plug it into the original?
No, second derivative. This is when we work on the second derivative, it's about concavity. So plug these into the second derivative. So I'm plugging, and that's the simplified version is right here.
I was about to do the
0
hard
doesn't
one.
work.
It just seemed fun.
Does it?
Yeah, I plug in 0, and you can do the original one. That's fine. If I plug it in here, 0, it'll be 8 over negative. This will be negative 2, right? Negative 2 cubed, and that's negative 8. So it's negative 1. We only needed the negative part. Plug in 3. The 8 will be up top. 3 minus 2 on bottom will be 1.
It's positive.
So it'll be 8 over 1 cubed, which is just 8, so it's positive. Okay, so I get rid of my test points, and I'm pretty much just got to write everything down. Concave up where it's positive at interval 2 to infinity. Concave down where it was negative on the number line, negative infinity to 2. Okay, and finally, points of inflection. Points of inflection will occur when the concavity changes. And it changed from negative to positive right here. So hold their thought, don't write it yet. You probably want to say, all right, x equals 2. There's a point of inflection because the concavity changed. However, we got to make sure up here, x equals 2, well, from yesterday. Remember our domain was all real numbers, but x can't be 2?
Yeah.
That was our domain. So 2 is not even in the interval. Sorry, in the domain. So we cannot include 2 for a point of inflection. So there are none.
Wait, does that mean that there was an asymptote?
And that's the last thing is we'll do asymptotes, yeah.
They never did a range. No.
Right, once we graph it,
Okay.
then we'll just look at it. Any second derivative questions? Simplify, second quotient rule, simplify, we did the number line. So last thing is asymptotes. I'm going to go up actually for now. 3 types of asymptotes. Let's go one by one. Vertical asymptotes. Do we have any, look at the original function here. Do we have any vertical asymptotes? there is
Two.
one. At x equals 2. Now, if we were able to cancel, which we found out doing the x-intercepts, this wouldn't factor. But if we were able to cancel, it would only be a whole. But we cannot cancel, so vertical asymptote at x equals 2. I'm going to go ahead and graph that. By the way, didn't we have points from yesterday where
We had
4, 6?
4, 6, and 0, -6.
Thank you. So it was y-intercept, there were no x-intercepts, and then that was a max, this is a min. Okay, let's go back up. Vertical asymptote x equals 2. What about horizontal asymptotes?
I don't think so. Nothing.
And when it's rational, what would have to happen for there to be a horizontal asymptote?
What if they cancel out?
That's a whole.
My bad.
What are you asking?
What would have to happen for there to be a horizontal asymptote? A certain condition.
The bottom would have to be
Denominator.
Bottom heavy. Thank you, Jane.
So there's not.
Remember that when it's bottom heavy?
No.
The degree of the denominator is bigger than the degree of the numerator. No, bottom, it has limits.
top heavy, bottom
Doesn't
heavy.
mean I remember
And-
it.
Limits, you got it, yeah.
No.
It was pre-calc stuff too.
Mr. Hunt, pre-calc was not my class.
Horizontal asymptote, okay. None. After we graph it. Last type of asymptote, I'm going to go to the bottom, is slant or oblique, depending on what your teacher called it. I know, but we're almost done. Slant or oblique asymptote. Is there a slant or oblique? Same thing. Slant oblique asymptote.
There's a slant.
There is. Do you know why? It's top heavy and the degree is 1 more. When the degree is 1 higher, actually it would. Oblique and slant, that means a straight line. There are also other shapes of asymptotes, but not lines. So if the degree is 1 more than the degree of the denominator, then there will be a slant or oblique asymptote.
So there's a oblique.
So there is a slant / oblique asymptote. How do we find it? What? Synthetic or long division. Very
I
nice.
don't have
that
room
stuff.
for this.
Synthetic or long division. Now I bet you guys were, you liked long division better.
I don't remember.
That's
I
okay.
like synthetic.
I think we did
I'm kidding, I know.
synthetics.
You probably like synthetic division better.
I don't know if I liked it. I just know that we
They just never stop seeing this.
So synthetic division was take the denominator, x minus 2 is a factor, therefore x equals 2 would be the root, and that's what we can divide in to x squared minus 2x plus 4. Did you do something like this?
Of course.
Something like a box type thing like this?
Well, I didn't do the box.
You put the, well, not a full box.
I didn't do the second box.
You write the coefficients. 1, -2, and 4. What do I do next?
Bring the 1 down.
Yeah, bring the 1 down.
Then multiply it by 2.
Multiply and add from here on out. So multiply by 2, get 2.
That's 0.
Add the column, get 0.
0.
Multiply by 2, 0 times 2, 0. Add the column, 4.
104. You know that'd be really cool if it was 101 or 101 down.
You bring the 1 down, and then you're basically multiplying here to get there, and then you add these and get 0.
okay.
And then you multiply 2 times 0 and get 0, and then add these and get 4.
So weird.
Now the original was x squared, degree of 2.
So you break it down.
So this tells you the degree goes down 1. So this is 1x to the first power. You can just write x. There we go.
Thanks.
Plus 0, that's your constant. This is the remainder, so I don't need to write that. For our purposes, we don't.
So it's just 1x is still oblique.
So
it's x.
so it is x, yeah. I mean 1x to the first power, that's x.
So
plus
that's
0.
the oblique.
That's the oblique
Which
asymptote.
is x.
X. So you go ahead and graph x, I will in a second.
Bro, it's one of those funky graphs. I know what type of graph this is.
Good. So I'm just going to graph x, diagonal y. Okay, now I graph it.
Oh, jeez.
So I'm going to be following increasing, decreasing, and concavity. You'll have, those are from yesterday, that increase, decrease, so you might have to look back for those. But I'm also going to be following this down here, concave up and down. So basically, it starts off negative infinity to 0, increasing. Okay, so it's, and remember, it goes along the asymptote at the extremes. So it's really starting off down here. It's increasing, it's going to go through that point, and that was the line. It's increasing to 0, x equals 0. So it's done increasing. Now this is from yesterday, decreasing 0 to 2. And all along here, from here up to 2, it is concave down, shaped like a frown. And so that makes sense. So it's going to be decreasing to 2, approaching the asymptote, concave down all along there, shaped like a frown. And there was the asymptote, the break. Now it goes up here to this section, and the rest of the way it is concave up, shaped like a cup, 2 to infinity, shaped like a cup. I'm going back, it's decreasing 2 to 4. So 2 to 4 is going down. That tells me it starts up here, goes down, until we reach, that was a local min from yesterday. And then it's increasing from 4 to infinity. This is at x equals 4, and it approaches the asymptote. Local max there, local min here, concave down, shaped like a frown, concave up, shaped like a cup. Let me say the last thing, which is range, and then I'll see what questions we have. Looking at this, I'm just going to write it here. The range is all the y values that our function has. So it takes on all y values down here, right, up to -2. So we're at low to high. Negative infinity has all the y values up until -2. I include -2 with a bracket because it includes -2. We have that y value. There's no y values between -2 and 6, but at 6, it does start over. We include 6, and then we go up to infinity. And that's everything. What questions can I answer on that?